There you go. Okay. Good afternoon, everyone. This is the first session, the last session for the OpenStack set of tracks, and we are going to talk about the how to properly manage a particular set of cluster frameworks for data processing using the OpenStack. This is something I'm working on, as I'm OpenStack storage QE here in Red Hat. The agenda for the talk, you can see it here. Just going briefly to OpenStack, even if I suppose that most of the people here knows what I'm talking about. The idea and the concept behind Hadoop, one of the most known big data framework, and then going to OpenStack Sahara, the component which allows you to easily deploy an Hadoop cluster in using your existing infrastructure. OpenStack. So in most of the cases, if you have worked with OpenStack, you have been exposed to this big picture. A bit scary because it shows you all the basic components and the interaction, how they work inside. The problem with this picture is that, yeah, it's scary for the beginners and it's even outdated. For example, there is no mention of Ironic, which is a new project. It was mentioned in the two talks before this. So I would like to move the focus to a layered view. Not all the components in the OpenStack world have the same importance. We can distinguish a set of components which are more core. No one is doing anything without Keystone for providing the identity authentication. Probably you want Nova in your system to handle compute nodes. Glance as well for the image handling, and Neutron is going to be more and more important with all the movement to software-defined networks and so on. Neutron is going to be more and more important. We have still core, but slightly less important components like Cinder for volume management, Swift the object storage, Ironic for bare metal, which could be maybe a bit core, but still not at the same importance as Nova. And then we have a set of other components which are less core. They are important, of course, but for example, HIT or Ceilometer, HIT for orchestration, it allows you to orchestrate the creation of resources. Ceilometer to monitor your stack. Horizon, it's quite important, yes, but you can access your components even without that. And there are some set of new applications. Sahara is one of these. Trove is another one, recently added to the set of released application, which are, I'm using the word application because they are services. They provide you something, but they are kind of application built on top of all the other components or many other components. Okay, let's move out from OpenStack for a minute, and let's move to Hadoop. But in order to talk about Hadoop, we need to talk about MapReduce, which is the programming model for a particular type of programs. And we are talking here about what is especially embarrassingly parallel programs. So you have a big amount of data. You can split your data, your input in the chunks which are totally independent one from the other. You can do some computation on each chunk independently, and then you can reassemble the results. And this was MapReduce was born in a paper by Google 11 years ago. So it's quite old technology at this point. The idea is to split the computation in two phases: a map phase, where you take a chunk of the input, you do something, and you output something. And the reduce phase, which takes all the input from the previous mapping phase. And especially both phases operates on couples of key values. And using the result of the mapping part, it does something else, and it gives you the output. I'm not going into the details on how it's used. So I'm going to focus more on the general idea and the integration in our OpenStack environment. One important thing is that mapping, both map and reduce, write their mapping. The output of the mapping phase is written down to the disk. What the framework does is to make it easy for the programmer to concentrate only on the mapping and reduce functions. What you need to provide for your MapReduce program is just the implementation of the two functions. The framework takes care of splitting the input, calling the mapper on the various chunk of input, writing down the output values, the intermediate results, shuffling them in the proper position, calling the reducer, and so on. If something goes down, if a node is killed during the computation, the framework will take care of restarting it. Of course, it's sometimes spent, but the data are not lost. The result is just computed again. And the Hadoop frameworks, which implements the MapReduce idea, it's a project originally born in, developed by Yahoo, but since then it's an open source project. It's now under the Apache Foundation, as many other components of the Hadoop world. We will see it in a minute. As I said, the framework takes care of all the operation of data partitioning, job scheduling and control, handling of failures. One important concept introduced here is the Hadoop Distributed File System, HDFS. It's a core component from the beginning. It's a distributed replicated file system. And so at the beginning, Hadoop was just HDFS and the MapReduce framework. Just a word about the jobs. Hadoop is written in Java, so the native languages for jobs is Java, but you can use also other languages using something called MapReduce streaming. And of course, in order to make it easier to write MapReduce jobs, other frameworks were born, like Apache Pig is a higher level data query language. So you write you express your program as a query. Kind of query, it's compiled in MapReduce. Still, this was Hadoop 1, what is called Hadoop 1, just HDFS and MapReduce. But I think 2 or 3 years ago, this was changed in what is now called Hadoop 2, where some of the part of the MapReduce framework has been generalized. So a new daemon was created, or a set of daemons called Yarn, which is yet another resource negotiator. And the idea is that HDFS is still important at the base of all the computation. And the idea is that, yes, you still have MapReduce as a possible computation model, but you can plug in other possible computational model here. So it's a more generic framework than before. And this is really a quite new thing still, even if it's 2 years almost. You can still find many documentation referring to the Hadoop 1 way of doing things. So things now start to be more interesting because you can plug other, as I said, other computational models and other daemons for the processing. But of course, they start to be more complicated. You have more potential moving parts. This is quite a scheme of how MapReduce works in the Hadoop 2 context. When I talk about Yarn, the resource manager, it's really the resource manager itself as a master, and then there are the node managers as slaves on the various computation nodes. And there is also the application master for each application which handles the execution of the application. And on the other side, we have, for HDFS part, we have the master node, called name node, and the slaves, which are called data node. And here we can see, for example, that the client talks to a central node, which have both masters for the Yarn and for HDFS. and they communicate with their slaves. So the green part is basically the yarn part, plus the application master, which is per application. So we can see that this application master is executing things here and partly here, and this application master is executing the application here and partly here. And here we have the slaves, the execution slave, again with the slaves of both parts, the node manager and the data node. So Hadoop now is an ecosystem of services, a lot of services. If you are starting it with Hadoop, it can be quite complicated. I've just named a few of them. Ambari, it's a provisioning framework to provision Hadoop clusters. HBase, a distributed database. Zookeeper, coordination services for the applications. Whozy, a workflow service for jobs. So it can handle also DAGs and handle a set of jobs together. Hive, data warehousing, querying, and there are others which are created. Some of them partially overlaps in their functionality, so it's really a changing background, and it will probably stabilize in the next years. Like it happened with the Linux distribution, something similar, there are some distribution which aggregates the various components and provides a set of ready components. Some of them, which are important in the Sahara context, are the Hortonworks data platform, Cloudera Hadoop downloads, and MapReduce. And this is just to give a picture of the number of components here. This is the taken from the release notes of the Hortonworks data platform 2.2, which was released, I think, not more than 1 month ago. And you can see that in the HTTP 2.0 version in October 2013, they were supporting the core Hadoop. This is the core Hadoop version 2.2. Those are all other various components, Pig, Hive, HBase. I mentioned some of them, but there are many more. And if you see, the newest version start to integrate more and more components in the distribution. So it's really scary when you start. But if you need them, okay, the idea is that if you need them, you start investigating and start using one of them. Of course, from the management point of view, this is really, really a hell, because you have to take into account the various daemons. So if we have our existing infrastructure managed by OpenStack, maybe we want to have something simpler to manage all of these. Just a quick note about Storm and Spark, because those are two different computation models than the standard MapReduce. And they are important in the Sahara context as well, because they are partially or quite completely supported. I will just mention that Spark is slightly different. We have seen that MapReduce is on disk, so it saves the intermediate results on disk, and it's two-stage, while Spark is in memory, so it's faster. It's as a functional API. The native language is Scala, but then you can program also in Java, Python. But it's still batch, so you have your existing data and you process them. And there is another one, which is Storm, distributed real-time computational system. So it's a completely different model. It's streaming. It processes the data as they come. We will see them in a minute again. And where we are in the move back to the OpenStack domain. Sahara. This is the description from their website. So basically, they try to provide an easy way to manage Hadoop clusters, allowing also some flexibility in the parameters you can specify in the configuration that you can inject into the Hadoop cluster. The project was originally called Savannah. Maybe you have heard about that. It was graduated in Ice House, and from Juno, it totally integrated. Even if now the integration process is a bit different, but still, it's already integrated. It provides different plugins for the various Hadoop distributions. We have seen Hortonworks, we have seen Cloudera, and there are plugins for some of these distributions. And of course, the supported set of Hadoop services, of the many we have seen, depends on the specific plugins. because not all the distributions provides all the possible services. And on the other side, not all the plugins, even if a distribution provides some service, maybe the plugins is not mature enough to support all of them. But this is, again, something which depends on the specific service. For example, I mentioned it before, Ambari, which is used for provisioning Hadoop clusters. And in fact, the HDP ships Ambari. And the Sahara plugins for HDP relies a lot on Ambari to do the provisioning. So it's just a thin layer over Ambari. This is also from the Sahara documentation, and that's how the service is built. So as usual, as any other OpenStack service, we have a REST API, the Sahara client. We have also a component for a plugin for Horizon, which is now part of Horizon. So if you install Sahara and you point your existing Horizon since Juno to the cluster, you will see a new tab. We will see it in the demo. And on the other side here, we have the abstraction layer for the data. We don't care about it too much. Of course, Keystone for authentication. We have the various vendor plugins which operates on the Hadoop VMs. Here is about VMs, because so far Ironic was not an official project. Maybe in the future, when we have a fully supported Ironic, then it will be easily possible. It should be easily possible to deploy also a cluster on bare metal. But for now, it's just VMs. EDP, so the Elastic Data Processing, is the component inside Sahara which takes care of jobs. And it can interact with Swift as well for taking the input and data, taking the input and writing the output of the jobs. And the interesting thing is that the image registry uses Glance and injects some metadata for each handled image in there. The provisioning engine used to do all the magic. Of course, interacts with Nova for the virtual machine. It can use also Cinder, because you can attach some volumes to each instance during the boot. And it can use Heat. There is, right now, the way Sahara works is with own engine for the orchestration and doing all the cluster creation and all the operation, or also job running. But there is an optional Heat plugin, so that Heat engine, so that it can use Heat inside. It's not the default yet. It's in Juno. It's quite stable, so I don't know if it will be enabled by default for Kilo. There are no blueprints for that now, but maybe. And here is a more a summary of something I already mentioned on the interaction of the various components. That's the things I was saying before. It's like really, Sahara is a service, but it's an application built on top of the existing technologies. Glance, as I said, for the image metadata, Cinder for the volumes you can attach. Swift is really important because it can be used as an input-output of data of the data of the jobs. So if you have some plugins in Swift that allows you to access an existing kind of storage with stuff like Swift on file, yeah, that's the way to go. But it can also store job binaries, so the executables and the libraries for the jobs. Heat has a double integration. I already mentioned the fact that Sahara can use Heat as an orchestration engine, but on the other side, you can also create Sahara resources using Heat. So you can create an Heat template, which creates a cluster template. Neutron, there is a direct support in addition to Nova Network, even if there are not many other new functions. Tripolo, because Disk Image Builder is used to write images so far. And Silometer, this is a new addition in Kilo. It will be a new addition in Kilo, can take notification from Sahara events. So what are the objects we can define? We will see them in the demo, so I'm going quickly through them. We can define groups of nodes through templates with all the parameters. We can define using the templates for nodes, we can define templates for cluster. Then we can create cluster. We can, of course, destroy cluster. We can scale cluster. Um, what we are working on, Sahara needs some, let's focus on the first point. When you want to create a cluster, you need a special image which has the Hadoop software preloaded on it. That's the image which is created using Disk Image Builder. That's the recommended way of doing it. Some provider plugins, I think Horton works currently, should be able to create, install the software on the fly. So you can take a simple plain image, just like CentOS with just Cloud Init, and that's it. And it should be able to do all the operation. Of course, it takes more time. And I will say go with this way. So pre-build your image with Hadoop stuff, and that's it. I will tell you how to do it in a minute here. The way to build images, as I said, is using Disk Image Builder. There is a special repository containing additional elements for Disk Image Builder, and a wrapper script which allows the generation of the images for the supported combination of both Hadoop sets of distributions and Linux-based distributions, mostly Fedora CentOS 6 and Ubuntu. But if you want to go for the fast way when you test it, just get the pre-built images from the project website. The vanilla one, so just plain Hadoop from the Apache website, or HTTP, but even Spark. When we want to execute on a job on our cluster, we can define the data sources for the job, both input and output. We can define the job binaries, which can be stored on Swift or in the internal storage. And using the binaries, we can define the job templates. There are some predefined type of job templates, Hive, Pig, MapReduce, so the classical one, MapReduce streaming, so MapReduce in other languages, and Java. Those are for Hadoop cluster, and the special Spark type for Spark cluster. And the type of executables and libraries and combination depends really on the type of the job. This is all documented on the project website. Once you have the job template, you can run it on an existing cluster, or you can tell Sahara to create a cluster on the fly, execute the job, and destroy the cluster with all the settings. Briefly, the table of the set of supported plugins. You see the distribution we mentioned are all here. Even up and Spark and Storm are supported just for Kilo for now. Not all of them are enabled yet in the default set of plugins. And mostly they are following upstream. If you see the version upstream and the version supported, at least in Kilo, not all of them. Hortonworks is a bit behind, but let's see. OK, demo time. We all love demo. Of course, given that many things can go wrong in case of demo, I just recorded it. So it's not exactly live demo, but it was live when I recorded it. So, so we are here in Juno. This is Juno from RDO packaging installed on CentOS 6. And this is our usual compute tab images. So this is Glance. I pre-registered an image. This is taken from the Sahara website. And you can see already here there is a new data processing tab. This is Sahara. I have my own image. What I'm going now to do is to go in the image registry, say to register the image. I can select one of the unregistered image. I set the username. This is the Cloud Init username, so that allows direct access without password. And then I have to specify which is the version of plugin and the version of the Hadoop which is supported. I can also add custom tags. Those are stored as metadata in Glance, and that's it. So I can change the tags and register the image. From this point onwards, I can use the image inside Sahara, and you can see the custom properties here. But maybe more interesting is the creation of node group templates. So going to node group templates, I'm going to create, I have to specify which plugins I want to, I want this node group template. And here we are. The name of the template, of course, this must be unique. The flavor I want to use for this, for the nodes in this template. If I want to attach some volume to my instance, the floating IP pool, which needs to be reached, which is used to reach the instances. And here is the set of processes. So those are the Hadoop services. Just a note, this is a functions to automatically open the needed ports, but I'm just, for now, using my default group. I just open all the ports, and that's it. So this is the set of processes available with the vanilla plugin. It's quite short. If you open that with Hortonworks, it will be like 2 times this, if not more. And we can see some of the plugins we have seen them, we have described it before, plus some other. This is going to be the master of my cluster. So I'm going to put Yarn, Resource Manager, Uzi, which is needed, the history server is just to see the jobs, and of course the name node as the master of HDFS. I can also, for each of the enabled services, I can go and change some of the parameters which are exposed here. So there is a lot of power for tuning. And then that's it. So this is the first template. And now I'm going to create other 2 templates. One, because those has only the master services. And here I'm going to add some slaves. I changed it. I said to add Cinder volume. I can specify how many volumes I want to attach and the size of them. And here I'm going to add the node manager and the data node. So this is just a slave. I'm going to cut it because we have only 10 minutes and maybe there is no time. I'm going just to add now another different templates, but let's go to the cluster template. So I have defined 3 different node group templates. And now I can define the topology of my cluster. The name. I can use specify that some of the services needs to have anti-affinity defined, so to not share the same computational resource. And this is the important part of the configuration. For each of the node group templates, I can say how many nodes I want from it. So I can configure other parameters for the cluster, for example, the replication, but I can change any of the other parameters. And that's it. You see here in the summary, I want 1 node from the which uses the master template, 1 node for the worker and M, which contains just a node manager, and 2 of the other type. And time to launch the cluster. And you can see for launching the cluster is just the minimum, the amount of information is really small. The template of the cluster, the image I want to use, the key pair to access it, and the private network, in this case for Neutron. And that's it. So it will take a bit of time. What's going on under the hood? Now it's waiting because it needs to wait on the availability of the instances. And if we go and check, just to be sure, we see that Nova is happily building our instances. And at this point, we just need to wait. It will take some time because I don't know why, but it took a bit of time with the resizing of the images. But we can, as the demo is recorded, we can happily skip forward. let's say in 10 minutes, it took like 8 minutes to complete the resizing phase and move from the waiting phase. Yeah, you see, it was stopped on the resizing. But now, moving forward, after like 10 minutes, 12 minutes, it moved to starting phase, so the nodes are ready, and now Sahara is connecting to each of them to run the various services. If you log in into the instances and you see the SSH logs, you will see all the instructions which are executed at this point. And after a few other seconds, we can wait on the fly. After a few other seconds of waiting, it should change, hopefully. If I didn't move to the active state. When the cluster is active, you can then, as I said, you can ask the Sahara to, for example, to scale it. So you can ask it, add another node. Now the cluster is active. You can add another node, or you can, or more nodes, or you can remove some of the existing nodes. Yeah, you see, we have our instances. Here a summary of each node group and the summary of the configuration. We didn't specify anything here, any specific configuration for the node groups. And an interesting thing is that in the summary of the cluster, here is the HDFS configuration we changed. There is a direct link to the various console. Those are Hadoop specific. Those are the console of the various components. This is the console of the HDFS. This is the web console of Whoozy. This is the one of job history server, and this is one of the resource manager, Yarn. I'm going to skip for now the consoles and just see how to launch a job. Please note, this is Swift. You see, object store containers. This is a container called a test, and I preloaded just a file with some input, nothing important, and a jar file containing the examples that you can find in the Sahara repository. In the data processing, now this is a bit tricky, but there is a blueprint to simplify the entire process. So let's hope for that Horizon reviewers will take some time. I'm going to define an input data source, and I'm saying that it's from Swift. In the test container, that the Sahara part is just something so that Sahara knows that it needs to check into the test container and call it output. I need to specify the username and password for now because this information is replicated on each node, and nodes needs to take the information from Swift and need to access Swift. So they need. After the data source, we need to define a job binary, and in this case, I'm defining a job binary from that jar file. And once I have this, I can define a job template. Again, the name is always the mandatory component. We have the type of jobs I mentioned before. And a MapReduce jobs needs a library. In this case, the library we uploaded before. Now, we can launch on a new cluster or on an existing cluster. And we need to specify the inputs. This is one of the data source we defined before. The same for the output, the existing cluster, and here we can specify some other configuration. That specific MapReduce jobs needs 2 parameters. So the name of the classes which execute the mapper and the reducer phase. And in this case, they are just simple examples which are not doing anything. Please consider, so as I said, this process is a bit complicated, but it will be simplified in the next version. All the things I showed you here, all those operations can be also done through the REST API and, of course, through the Python client. So you can do it on the command line as well. Now, the job is pending. It will switch to the running state, but I'm going to skip 1 minute and go directly to the successful part. If you have any question in the meantime, I can show you I can show you that I can really access the web console, or I can show you how to create an use Hit to create a Sahara resource, a node group template, or if you have any question.
Are you able to do the brownfield installation? So you have the existing Hadoop cluster, and then create the power of the cluster by Sahara.
So you're asking if I have an existing cluster and I want to, no, it should be managed by Hadoop. So you are starting with your infrastructure, you have your cluster, you have OpenStack, and you start managing your cluster with this.
Do you need for a Swift connection with Hadoop any plugin?
So the question is, how do I connect for Swift and Hadoop? There is in the meantime, we have the resulting output pseudo folder and something written there. So basically, the Sahara programmers pushed some patches to upstream Hadoop so that there is a file system connector inside Hadoop that is able to access Swift. It's already there, yes, exactly.
How easy or how hard it will be to install the Cloudera manager directly from this stack?
Would be to install the?
To install the Cloudera manager.
I didn't touch that part. So the question is how to install the Cloudera manager. I didn't touch that part yet. It was not enabled by default, so I cannot answer the question right now. But I know that as I said, the Cloudera plugins in Sahara is contributed by Cloudera developers. So I don't know if they are going to use also their manager, or if they are going to bypass that and using some other things. I didn't check this part yet, but we can check afterwards.
Another question, I saw in the info page that there is a specific line for HDFS. Oh, sorry. In the info page, there was a specific line for HDFS replication. Can we change all the settings for Hadoop HDFS directly from there?
I didn't check if all the settings can be changed, but many settings are exposed. They need to be explicitly exposed in the code. I don't know if they are all exposed there.
Okay, but the ones that are, can we change them directly from that page? Let's say the examples had an HDFS replication of 2. Let's say we want 3 or 4. Can we change it directly?
That was part of the cluster template. So I explicitly said in the cluster template, I want this parameter to be 2. So the DFS replica 2. So yeah, it's something I set explicitly. The default was 3. I can change it yet. Yes, there.
Okay, thank you.
Okay. I guess time for another question. Or I can run in the creation of the Hit template in the meantime. If there are no other questions, and then I will close. Yeah.
Can you actually access the Ambari or the Cloudera manager,
yes,
even if you install it via the Sahara?
Yes. I showed them before. They are in the when you define the cluster in the cluster template, when the cluster is running, if you click on the cluster properties, you can see at the bottom of the page the direct link to all the consoles of the services running there. So to Ambari, Yarn, Whoosy, and so on. So just a click away.
Okay, and that means that you can do anything with the console. There are no limitations because you are using OpenStack.
No, but of course, if you want to manage your nodes, it's better to do that through the scaling part of the Sahara. So if you want to add a node to the cluster, you do it through it's better for you to do it through the OpenStack interface.
Okay.
I think that.
Thank you very much, Luigi, for this session. I think the time has come. So.
Okay. If you want to provide some feedback here. Thank you.